For today's lesson, we are going to discuss about the scalar product, or sometimes it's called dot product, in the vectors chapter. Have a look at this formula. A dot B equals to the modulus A times the modulus B cos theta. So for the theta here, actually it represents the angle between the vector A and B. So the function of the scalar product is actually to find the angle between two vectors. So how to find out the dot product here, A dot B, is also given in the formula list as below. So let's say if A's vector is x1, y1, z1, and for the B's vector is x2, y2, z2, then the A dot B should be x1, x2 plus y1, y2 plus the z1, z2. This is how we calculate for the dot product. As for the modulus here, is just the magnitude of the vectors that you have learned earlier. And then from here, by using this formula, we should be able to find out the angle between the two vectors. Let's have a look at the sign of A dot B here. There are three different cases. A dot B's value can be more than 0, it can be equal to 0, or it can be less than 0. But the important one is at the part 2. The second one, when the dot product equals to 0, it means that the two vectors, they are perpendicular to each other. So have a look at the first one. When the A dot B is more than 0, it means that the angle is in between 0 to 90, which means that the angle is an acute angle. Why is it an acute angle gives you a positive dot product? Because if the angle is acute angle, which means the angle should be in the first quadrant. If you sub into here, cos the angle from the first quadrant, it must be a positive value. And the magnitude here must be always positive. So positive multiplied with positive and multiplied with positive, it will end up with a positive value for the dot product. As for the third case here, if the angle is in between 90 to 180 degree here, which means that if the angle is obtuse angle, the dot product should be less than 0, because obtuse angle is in the second quadrant. If you cos an angle from the second quadrant, it will be a negative value. So negative multiplied with positive magnitude and positive magnitude, the whole thing becomes a negative value, and therefore the dot product is less than 0. As for the second one, when they are perpendicular, if you sub the 90 degree into the cos theta, cos 90 is actually equal to 0, and 0 multiplied with anything here is still equal to 0, and therefore the dot product is equal to 0 when the two vectors are perpendicular. There's one important thing that you got to take note. Theta is the angle between vectors pointing out or in from the vertex. Let's say have a look at the first diagram over here. If you are looking for this angle theta, then you have to make sure that the two vectors that you are going to dot must be both pointing out or in from the vertex. So the vertex is over here. For this case, you have to make sure that both out or both in. The direction of the vector is very important in the dot product. So let's say for the second diagram here, if both vectors are pointing in, then the angle that you're looking for is the angle here, the angle between both the vectors, or the opposite angle is the same. As for the third diagram, if the vector is one in and one out, then you are actually not looking for the angle between the vectors here, but the angle beside it. Because when you extend the vector B over here, then you notice that B dot A or A dot B from the vertex, when the both vectors are pointing out, you are actually looking for this angle. Now let us try to solve this question by using the scalar product. Have a look at the question here. Given that the position vector of PQR are given by these three vectors. Position vector of PQR means this is OP, OQ, and OR. So you are asked to calculate the angle PQR. So what we need to do is try to draw the angle, roughly draw the angle PQR, and you're asked to look for this angle. So the first thing to do is you have to figure out which two vectors to dot by using the dot product. So as I mentioned earlier, here's the vertex, and if you're looking for this angle, you must make sure that the two vectors that you're going to dot must be both pointing out or both pointing in from the vertex. So for this case, you can either take the QP dot the QR. So I write down over here, you can either QP vector dot the QR's vector, or the second one, it can be both in, which means it's PQ dot with the RQ. So you can use either the first one or the second one to dot to get the angle. You should be able to get the same angle. So let's say I'll just make use of the first one, QP.QR. So the dot product's formula is actually given in the formula list. So it's A dot B equals to A's magnitude times the B's magnitude and cos theta. So now just change it. The A's vector should be the QP's vector. So I just write the QP dot the QR equals to the QP's magnitude times the QR's magnitude and cos the theta. And the theta is the angle PQR that we are looking for. So the first thing what we need to know now is how to find QP and how to find QR. So to find QP, you can just take OP minus OQ, which is 1, 2, 3 minus 5, negative 3, and 0. And you will get a negative 4, 5, and 3. As for the QR, you can take OR minus OQ, which is negative 104 minus 5, negative 3, 0. So the QR should be equals to negative 6, 3, and 4. And according to the scalar product, you're supposed to find out the magnitude of the QP and the QR. So now let's find out the magnitude of the QP first, which is equals to square root of negative 4 square plus 5 square plus 3 square. So eventually you should get square root 50. As for the magnitude of the QR, is equals to square root of negative 6 square plus 3 square plus 4 square, which is equals to square root 61. Alright, so now we just need to put everything into this scalar product. So according to the formula, I will sub in the QP.QR, which is negative 453 dot with the negative 634 equals to the magnitude of QP is square root 50, magnitude of QR is square root 61, and then cos theta. And for now, how to find out the dot product? According to the formula earlier, we just need to take x1 times x2 plus y1, y2 plus z1, z2, which means it should be 24 negative times negative 6, negative 4 times negative 6 is 24, plus 5 times 3 is 15, plus 3 times 4 is a 12. That's how we calculate the dot product, and hence cos theta should be equals to 24 plus 15 plus 12. It's 51 over square root 50 and square root 61. So hence we can calculate for the angle, which is equals to 22.6 degree. That's the angle for the angle PQR that is requested by the question here. Let's see how we apply the scalar product into the past year question. So have a look here for the October-November 2013 paper variance 11. So for this question, you are given a diagram, and this diagram shows a pyramid of OABCD, where the vertical edge OD over here is 3 units in length, and the point E is the center of the horizontal rectangular base OABC, which is over here. And the sides OA, AB have the length of 6 units over here, and the 4 units over here. So the unit vectors IJK are parallel to OA, OC, and OD. So the IJK's direction is given, and we have to answer the vectors according to the IJK direction. Part 1, you are asked to express each of the vectors DB and DE in terms of IJK. So have a look at where is DB. DB means from here, point D to the point B. You have to describe by using the IJK direction how you move from the D to B. From D to B in IJK direction. If you feel that it's a bit hard to see in this direction straight away, then you can actually split the DB into OB minus OD. Then it will be easier, because OB means you have to move from O to B here in IJK direction, which means you just need to move along the I direction for 6 units and the J direction for 4 units to reach from O to B, which is 6, 4, 0, the vector of the OB. As for the OD, OD is over here. So you just need to move 3 units along the K direction, which is 0, 0, 3. So this gives you the direction of DB, which is 6, 4, and -3. As for the DE, have a look at the DE. DE is from here to here. So same thing, if you feel that it's a bit hard to move from D to E through the IJK direction, you can actually split into OE minus OD. So for the OE's direction, let's see how to move from O to E. Since E is a midpoint, it's in the middle of a rectangular shape, then we can move along the I direction halfway through for 3 units, and then move along the J direction for 2 units halfway through the 4 units to reach the E. So it's 3, 2, and 0. As for the OD, we have found out earlier is 0, 0, 3, and hence DE is 3, 2, and -3. That's how we find out the DB and DE in terms of IJK. As for the part 2, use the scalar product to find the angle BDE. And usually the part 2 is related to the part 1. Have a look at the part 2. If you just draw the angle BDE, let's say this is angle BDE, and you're asked to find out this angle, then you have to make sure that the 2 vectors that you're going to dot must be both pointing in or both pointing out from the vertex here. So according to the vectors that we have found out in part 1, DB and DE, if you want to use it in this question, then it's easier to make both vectors point out from the vertex, which is DB here in this direction, dot the DE here in this direction. Both vectors point out from the vertex. Alright, so what we do here is use the dot product DB dot DE equals to the magnitude of DB times the magnitude of DE cos the angle. The angle is the one that we are looking for, the angle BDE. So let's sub in the vectors. 3, 2, -3, and the magnitude is 6 squared, 4 squared plus -3 squared. The other one is 3 squared plus 2 squared plus -3 squared cos theta. And do you still remember how to calculate for the dot product? Is x1, x2, so 6 times 3, 18, plus 4 times 2, 8, plus 3 times 3, 9. As for the magnitude, you just need to do some calculation over here. So 9 plus 4 plus 9, 22 cos theta. And hence we know that the cos theta is equals to 35 over square root 61 and square root 22. So you just need to press your calculator to get the final answer. Let's check for the final answer here and see whether is it equals to 17.2 degree. For the angle, you just need to leave your answer, the final answer, correct to 1 decimal place. So it's 17.2. So let's check for the answer. Yes, it's correct here, 17.2. So this is about scalar product. So that's all for the lesson today. Thanks for watching and see you in the next video.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.